All right, sorry I can't be at school today. We're going over the Pythagorean theorem. So hopefully this isn't too hard of a lesson for you guys to learn via video while I'm not here. Because you've probably done Pythagorean theorem before. We've actually done it already this year. We just haven't had a whole lesson over it. So you have to have a right triangle, first of all, to use the Pythagorean theorem. So you have to know that one angle is a right angle. And the Pythagorean theorem, you've probably heard of as a squared plus b squared equals c squared. I think a little bit better way to remember it is leg squared plus leg squared equals hypotenuse squared, because not everything is going to be labeled with an a, b, and c. Okay, so we want to take our two legs, square them, add them together equals our hypotenuse squared. So your hypotenuse is always across from your 90-degree angle, the right angle, and the other two sides of that triangle are called the legs, and it doesn't matter which one is which. So let's look at our examples here. We have example A, our triangle has a hypotenuse across from the 90-degree angle here of x. Hypotenuse, and then my legs are 8 and 15. So I'm going to plug into that leg squared plus leg squared equals hypotenuse squared. So 15 squared plus 8 squared equals x squared. Okay, you'll definitely need a calculator today. 15 squared is 225 plus 8 squared is 64. After you square your numbers, you're going to add together 225 and 64, which is 289, equals x squared. Once you get to this step, we want to get x by itself, so we're going to cancel out that squared by square rooting both sides. On my calculator, I'm going to take the square root of 289, and I get 17. So 17 equals x. That's my missing side of my right triangle. Okay, so for example B here, again, x is this hypotenuse, and my legs in this one are 8 and 12. Doesn't matter which leg goes first. So I'm going to do 12 squared plus 8 squared equals x squared. 12 squared is 144 plus 8 squared is 64. I'm going to add 144 and 64 together, which is 208, equals x squared. Your last step is to square root both sides. So on my calculator, I'm going to square root 208. It tells me in the directions to round to the nearest tenth. So when I square root this, I get 4.4222051. And to the nearest tenth, that's one decimal place. So I look at the number after it, which is a 2. That is not going to change that 4. So 14.4. Okay. Now for C, if you want to go ahead and this missing side, just put an X there since it wasn't there, you can. Your hypotenuse in this one is this 21. It's across from that right angle. So your legs are X and 10 in this one. So we're going to set it up. 10 squared, leg squared, plus leg squared equals hypotenuse squared. 10 squared plus X squared equals 21 squared. I'm going to do my squared. So 10 squared is 100 plus X squared equals 21 squared is 441. And then I just have an extra step when I'm solving for leg. I have to isolate my x squared next, so I'm going to subtract 100 from both sides, which will give me 341 equals x squared, and now I do my square root on both sides. So square root of 341, it's 18.46, okay? So if it's 18.46, the 6 is going to bump my 4 up to 18.5. 5 or more, you go one more. Okay, example D, here's my right angle. So the 25 is my hypotenuse. My legs are 24 and x. So x squared plus 24 squared equals 25 squared. I'm going to do my squareds. So 24 squared is 576. 25 squared is 625. Isolate your x squared. If it's plus 576, we're going to subtract that from both sides. X squared comes down. Subtract your 576 from 625, you get 49. Last step, square root both sides. The square root of 49 is 7. Okay? So on the back of the notes page, it talks about the converse of the Pythagorean theorem, which says if a triangle has side lengths of A, B, and C, and A squared plus B squared equals C squared, then the triangle is a right triangle. Okay, so the two shorter lengths that they give us are going to be our legs. The longest one is always your hypotenuse. We're going to plug those numbers that they give us into the Pythagorean theorem. And if both sides of my equation equal out, they equal each other, then that means it's a right triangle. So example 2 says, which set of lengths could be the side lengths of a right triangle? So part A, they give me 8 inches, 15 inches, and 16 inches. The two shorters are the legs, and the longer one is your hypotenuse. Okay, so leg squared plus leg squared equals hypotenuse squared. And we're going to square everything. 8 squared, 64. 15 squared is 225. Bring down your equal sign, then do 16 squared, which is 256. You're going to add that left side together and see if you get 256. Does 64 plus 225 equal 256? No, if I add these, I get 289, which does not equal 256. That means that those three sides are not a right triangle. Not a right triangle for this first one. Let's try the second one, 4, 8, and 10. So the two shorter ones are my legs. So 4 squared plus 8 squared, we're going to see if that equals 10 squared. 4 squared is 16. 8 squared is 64. 10 squared is 100. Does 16 plus 64 equal 100? No, this is 80. 80 is not equal to 100. So again, those three lengths are not a right triangle. They do not make a right triangle. Okay, so let's try this last one. I have 10, 24, and 26. So I'm going to plug in leg squared plus leg squared equals hypotenuse squared. Okay, 10 squared is 100 plus 24 squared is 576 equals 26 squared, 676. Add this side, I get 676, which is the same as 676. Both sides equal each other. That means these three lengths can be a right triangle. So C was the only one. Okay, then we have a couple word problems, and you'll have some word problems on your Delta Math. So you'll want to draw a picture. Well, first read it, then draw a picture, and then you're going to be using the Pythagorean theorem, obviously. Example 3 says you start driving north for 6 miles, turn right, and drive east for another 9 miles. At the end of driving, what is your straight line distance from your starting point? Round to the nearest tenth of a mile. Okay, so for those of us that don't know, here's your compass. Okay, so I'm just going to make like a little starting point. I start driving north, this direction, for 6 miles. I'm going to make it a little bit shorter. 6 miles. Then I turn right, and I start going east, 19 miles. At the end of driving, what is your straight line distance from your starting point? So they want to know this distance here that I just drew in pink. So you're making a little right triangle. You just drove the legs of that right triangle. You're trying to find that hypotenuse. Okay, 6 squared plus 19 squared equals x squared, or if you want to use h for hypotenuse squared, you can. 6 squared is 36. 19 squared is 361. I'm going to add those together. 397 equals h squared, hypotenuse squared, and square root both sides. If I square root 397, I get 19.92. Tells me round to the nearest tenth again, so about 19.9 miles. Okay, last word problem. This one's a little bit trickier. A 50-foot ladder is set against the side of a house so that it reaches up 30 feet. If Alonzo grabs the ladder at its base and pulls it 5 feet further from the house, how far up the side of the house will the ladder reach now? It gives us a hint. The answer is not 25 feet. Round to the nearest tenth of a foot. Okay, so basically the ladder with the house is going to make a triangle. So I'm going to draw a right triangle. Okay, so my ladder is set against the side of the house. So my hypotenuse is my ladder. This is my ladder. And it's a 50-foot ladder. And it's set against the side of the house, so it reaches up 30 feet. That means from the top of the ladder here to the bottom of the house, it's 30 feet. Now, don't even pay attention to the rest of the problem for right now. Before we worry about him grabbing the ladder and pulling it 5 feet further, we need to know how many feet it starts out as away from my house. So we're going to have to actually do Pythagorean theorem twice in this problem. That's why it's a little bit tricky. But I wanted to make sure we went over it because on the Delta Math word problems, you might come across one that's kind of like this. So I have my hypotenuse is 50. My legs are 30 and x. So I'm going to plug those in to Pythagorean theorem. Square my 30. Square my 50. Subtract 900 from both sides. X squared equals 1600, and then I'm going to square root 1600. Okay, so the ladder, and I get 40. The ladder starts out 40 feet from the house, the base of the ladder. So now it says if Alonzo grabs the ladder at its base and pulls it 5 feet further from the house, how far up the side of the house will the ladder reach now? So what's happening, and I'm going to draw another little triangle. He's pulling this 50-foot ladder. It's still a 50-foot ladder, thus is not changing. But he's pulling it this way 5 feet further from the house. So we know that starting amount at that base is 40. He's pulling it 5 feet further, so now it's 45 feet on the bottom there. So I just added 5 to that 40 feet we found in the first step. Now it wants to know how far up the side of the house, that's this part here, x, is the ladder. Okay? So now I'm going to do Pythagorean theorem one more time. And I have my legs are 45 and x, so 45 squared plus x squared equals my 50 squared. Okay, so 45 squared, 2025. 50 squared, we know from the previous part, is 2,500. I'm going to take my 2,500 and subtract 2,025 from both sides. Which is going to give me x squared equals 475. And I'm going to square root both sides. The square root of 475 rounded to the nearest tenth is 21.8. This is my final answer. Okay, so you might not even get one like that on Delta Math. They might just be more simple, like example 3. But I just want to make sure we went over it in case one does pop up on yours. Okay, so you guys have a Delta Math to work on. If you need help, make sure you're asking Ms. Gaddis, and I will be back on Monday. You guys do have a knowledge check on Monday over Pythagorean theorem.